Okay, so what we were supposed to do today in class was what's called the density inquiry experiment. So this was an experiment where essentially I give you as little information as possible, and then you find what I ask you to find. That's the basic gist of an inquiry experiment. So in this case, what I was going to give you was information on what you were expected to find, and information on what you had available to you to find it, and then you would go out and find what I asked you to find. Most of the things that I was going to ask you to find, and actually I think everything, I think all the stuff I was going to ask you to find was density values. So just to show you exactly what I was going to ask for. Let's see here. Go ahead and pull these files up. So this is the lab handout that you would have been given in class today. And there are 5 different parts to the experiment, parts A through E. And then there are some questions at the end as well, which I won't get into right now. But in each of these sections here, you're finding the density of something. So in the first part, you are confirming the density of water. Now, the reason that I say confirm there is because you should know the density of water already, or you should very soon know the density of water. It's one of the more well-known constants, if you want to call it that. It's not truly constant, but one of the better known physical properties, maybe, in all of the science classes you hear. It's just 1 gram per mil. It's mainly so well known because it's very useful, and also it's so simple. Just 1 gram for every milliliter of water. And so you are going to be confirming that in the lab. And so you would do that with some graduated cylinders and some mass scales, some things to weigh it with. You would do a similar thing in part B. So in part B, you would do, it was practically the exact same thing, just with something that's not water. So you would do that with an unknown liquid. In part C, you would do the same type of thing. You're still finding the density, only now you're doing it with a regular solid instead of a liquid. So you would find the length, height, and width of a piece of metal. You would weigh the piece of metal, and you would use all that information to get the density of the metal. Part D is also a solid again, but this time it's irregular, so it's not something you can measure with a ruler. So they're like little crystals and things that are not regular in shape. And then part E was measuring the density of beakers using what we call a metal overflow can. Now, what we're going to do, and what actually, truthfully, what you are going to do, because I'm not going to sit down and work through it with you for a couple different reasons, is you are going to do parts A through D, or a version of parts A through D, on your own, and then turn that in. Part E, unfortunately, there's just no way for me to have some way for you to do that on your own at home. You're not going to need any materials for this. It is all just on your computer. I have images and stuff that we'll look at in just a second. Similarly, at the very end, these questions, I do expect you to have these questions answered in what you turn in. And if you have any questions over them today before we finish talking, I can answer those questions. They should be pretty straightforward in terms of getting the answers to these. None of them are too vague or overly wordy, so you shouldn't have too much trouble with them. But if you have any questions before we finish up, I'll be happy to answer those. But for now, let's go ahead and talk about how I expect you to do this makeup lab, because I don't want us to lose a lab. I'm trying my hardest to make sure that we have all of the labs that I told you we would have. We actually have in the class. So right as I was getting on here, I created an assignment in the class Blackboard site. So if you go, let me go to the student view here. So if you go down to the online labs and you click on that, and you scroll down to the bottom here, there is density lab makeup for group B. And there are two files here. Those two files are this one, the one that we've been looking at so far, and this one. So this file just has images and data that you are going to use to answer questions in the other file. That's all we're using this for. So you won't actually be turning this file back into me. You will just be using the data that I have on here. So let's talk about using this data. So I mentioned that I want you to do parts A through D. We're going to do that using the pictures and data from the other file. So for example, in part A, it says confirm the density of water using a 50 ml graduated cylinder, determine the density of water in grams per milliliter, do at least 3 trials using different volumes of water each time, report the average and the percent range for the density values. Now, obviously we're not going to actually be using a 50 ml graduated cylinder. We're just going to use the images here and the data that I give you. Now, not all these are 50 ml cylinders either, and that's fine. It doesn't really matter. But I have here pictures or illustrations of water in a cylinder. And so you are tasked with reading the volume of the water in those cylinders, and then using the masses that I give you, and I've attached to each of those, to find the density of water in each of these 3 cases. So here's one, here's the second one here, and then this is the third sample of water here. So just to remind you also, when you're reading volume from a graduated cylinder, you're always reading from the bottom of the meniscus. So you notice here how it kind of dips down like that. It's not flat. Water does that in real life. If you put water into a glass tube, it forms this meniscus shape, this curved shape. And you will read from the bottom of that meniscus. That is where you make your measurement, is the bottom of that meniscus. So each of those, I expect you to get the volume from the cylinder. I just give you the mass because there's no way that you can measure the mass just from looking at it. So I give you the mass, and remember, density is equal to the mass divided by the volume. So you will take the mass I give you, you will take the volume that you read from the cylinders, and you will find your density. And you will have 3 of those. So to get the average, just to remind you how to average something, if you have something that is maybe 2 and 3 and 4, now these are not going to be the numbers you get, not even close, just for simplicity's sake. Say you had 3 different measurements. One of them was 2, one of them was 3, one of them was 4. To get the average, you would add all the measurements together and then divide by the number of measurements. So because I had 3 measurements, I'm going to divide by 3. So my average here would be 3. Again, I just picked those just to make the math easy on me, because I'm lazy, I guess. but that's how you would get the average. Take all three numbers, add them together, divide by the number of measurements, which in this case would be 3. The percent range is right here. So the percent range, which I will also want you to give me, is the highest number that you measured, which would be the density. Again, these are the density values that we're looking at here. So your highest density minus the lowest density. So it should give you a relatively small number. You'll have a relatively small number at the top of this fraction, divided by that average, times 100%. That is your percent range. So you should have a pretty small percent range. If your percent range is 10% or higher, you probably did something wrong. I didn't actually calculate the percent range myself, but I tried to get numbers that were, because when I was making this, I just made up mass numbers. So I tried to make them so that they would be fairly close, a pretty small percent range. For certain, if you're getting 20, 30, 40% range, something like that, you did something wrong. It shouldn't be that big. But I believe when I was selecting and creating the data here, you should get less than 10% percent range. One other quick note here about reading the volumes off of these cylinders, and this is going to be true for all of the measurements that you make in this lab. You always want to estimate 1 digit past the markings. So just as an example here, just because I don't want to give answers away here, I'm not going to actually read one of these. But let's say we have another cylinder here. Okay, so that should be 10 markings, or 9 markings in between, which gives you 10 divisions. So let's say this is 7 mils, this is 8 mils, and we have liquid that goes like so. Again, I'm very poor at drawing, but oh well. So we have liquid here. I'm going to read from the bottom of that meniscus. So right there. So that would be the bottom. And so when I'm writing down the volume, I'm going to count the marks here. So I know it's 7 something. It's not to the 8 yet, so it's 7 something. So there's 1, 2, 3, 4, 5, 6. So it's 7.6 something. Now the markings would only give me 6. Did I get the right number? Yeah, okay. So yeah. So we have 7.6 something. So I only have markings for every 1/10 of a mil. However, anytime you're measuring something with your eyes, so you're reading a measurement, there is some amount of uncertainty in that, and that can be a bad thing. But then on the other side, you can see that this line here is closer to the 7 mark than it is to the 6. So writing 7.6 or even 7.7 wouldn't be right, because I can tell, because I have eyes, that it's somewhere in between the two, and it's a bit closer to the 7 than it is to the 6. So it is perfectly fine and legitimate and actually expected, and I am expecting you to do this as well, to estimate 1 digit past the markings. So if you have tenths marked, then you would estimate the hundredths place. So since I think this is a little bit past the halfway mark, I might say this is 7.67. Now maybe you think something different. Maybe you think it's 7.66, 7.68, and that's perfectly fine, as long as you are reasonable in your estimation. Now if you looked at that line right there and you told me, oh no, that's right on the 7.7 line, like that is just 7.70, I would say you need to get your glasses prescription checked, because that is clearly a little bit below the 7.7 line. But as long as you're, as long as I can look at it and be like, oh, okay, I can see why you might think that, I'm not going to take off any points for your estimation of something being different than my estimation. It is truly a subjective estimation. But if there is clearly an objective way to look at it and say, okay, that's just wrong, then I might take points off. But if it is purely subjective, where I think something is 6.15 and you think it's 6.16, well, okay, that is just people seeing things slightly differently, and that's perfectly fine. Okay, so that is part A. And I know I spent a good bit of time talking about part A, but a lot of what I just said is just going to carry over to all the other parts. Are there any questions so far about part A we've done so far?
No.
Okay, if anyone does have questions and you don't have a mic where you can talk, just go ahead and type them into the chat, which, by the way, if you've never used Collaborate before and you don't know where the chat is, this kind of magenta arrow down here, click that, and it's this tab right here. You can type stuff in. So, that's not how you spell hello. There you go. So you can type things in there, and I will get to them, even if I've already started talking about something else. I'll come back and check those. Okay, so in part B, it is exactly the same thing, just not water. So with water, we weren't trying to find the density, we were just trying to confirm the density because we knew it beforehand. This is going to be exactly the same. I just give you 3 different images of different liquids, and it is just one liquid in 3 different cylinders. And I give you masses, just like with the water, but now I'm going to expect you to find the density, and it will not be 1 gram per mil. It's not going to be crazy different than 1 gram per mil. Most liquids are actually fairly close to 1 gram per mil, just because most liquids are water-based. There's some organic stuff that is a decent bit lighter, but even those aren't like 0.2 or anything like that. So this will be fairly close to 1 gram per mil, but it's not going to be 1 gram per mil. So you'll just do the exact same thing here. I did, when I was making up the data for this section, I made sure that all 3 of the densities should be the same. So if you get 2 densities that are very similar and then one that's way different, either you made a mistake or I made a mistake. And I don't think I made a mistake, so you might double check what you did before you send me an email. But if you double and triple check your work and it's still giving you different numbers, go ahead and send me an email. It is completely possible I just made a mistake. Okay, so that's part B. And just like in part A, you should give me an average and a percent range for that for those densities. So you should have 3 densities, give me the average of those densities, and then the percent range of those densities. And again, all 3 of the densities should be very, very similar. Part C, unfortunately, there's not really a great way to get a 3D shape and to like measure it with images on a computer. So instead of doing a 3D shape and measuring and then weighing it, I'm just going to have you read 4 different images here of measuring something with a ruler. This is pretty much what that section was testing you over anyway, because there's plenty of other things where we measure the density, and measuring the mass isn't all that difficult. So all I expect you to do for part C, or part 3 as I call it here, is just to look at these 4 images. So 1, 2, 3, 4. And give me your best estimation of the size of these 4 things. So we have the red line here, the skinny red line here, this crayon, I guess, and then this pencil. So all you're giving me is just the size of the measurement there. And by the way, I realize that the pencil is going back behind the 0. Pretend like it's not. So just essentially just read from the tip here down, and whatever you get from that, read that.
So we're just measuring, oh, I'm so sorry.
Oh,
we're just measuring the length here, right?
yes.
Okay.
Yeah. Yeah. Just the one-dimensional length. Don't try to like print it out and take that ruler and spread it over the other way. No, just the one dimension. Just the length. Yes. So you'll have one length for this, whatever you think that is. It'll be 2 something, obviously. This one will be 3 something. This looks like it's pretty close to the 18 mark. And then this one is fairly close to the 9 mark. So you'll have 4 different distances, and just keep in mind here that first of all, I do want you to accurately measure it, but also the main thing I'm going to be looking for is to make sure that you are estimating, again, that 1 digit past the markings. The one kind of exception to that is, or the kind of tricky, I guess you could say, is this one, because there's only 1 mark between the centimeter marks. So you have the centimeters and the half centimeter marked. Because of that, because there aren't tenths marked, in this case I would only expect you to go to the tenths place. So you would have some number here, like 18 maybe, and then you would put something there, and that's as far as you should go. Since there aren't tenths marked, there's no way I could expect you to know what the hundredths place is, because that's just not possible, not with those markings. Any questions about that? If you have questions, you can type them in or ask them here in a minute. So the last part here, part D or part 4, apparently I'm not good at keeping my numbering system straight. That is the irregular solids. When you measure an irregular solid, it's in some ways a lot more difficult than a regular solid, because measuring the volume of the solid can't be done with a ruler or with calipers or anything like that, just because it is irregular. And so instead, usually what is done is the volume is measured through water displacement. So if you're familiar with Archimedes, Archimedes was a Greek, I think he was Greek, philosopher, I think was what they called them back then. They were essentially the scientists of their day. They were thinkers. And he filled his bathtub full of water and then hopped in and flooded his house, or wherever he was. And he was the first person, at least, to be written down in history as realizing, hey, things can't occupy the same space. If you take something and you dunk it into something that is already full, something has to give in order to overflow that thing. You can't occupy the same space as something else. And so when we put a solid into water, it's going to push the water out of the way. It's going to displace the water. And if we have that water in a measuring device, like a graduated cylinder, we can measure how much it gets displaced, how much of it gets pushed up and out of the way. And so that's what we're doing here with these. So we have some water in a cylinder, and then we dunk a piece of jade into the cylinder, and the water goes up. And so the difference between these volume measurements is the volume of the jade. The water will go up exactly the same volume as the volume of the piece of jade, because there's no other reason for it to go up. The only reason it would go up is if something was pushing it up. And so the same thing is going to be done here with this other just regular rock, I guess. It's not jade, it's just regular rock. So it goes from 50 to 20 to 75. And so in each of those, I also give you a mass that you can use. And so all I'm asking you to do from these is to find those two densities. There's not going to be a percent range or an average or anything like that, because they are two different densities. It's just it was more difficult to find images that would work for this. That's the main reason why I only have two of these. But again, all I'm asking you to do here is to find those two densities. And by the way, not that it's all that hard to find the density of this, but if you look up the density of jade and it's not what this density is here, it's not what I gave you, that's perfectly fine. I intentionally made the density different than what's on Google, just so that you couldn't just Google, what's the density of jade and then just type that number in. So it is different. It's not dramatically different, but it is different. Okay. So like I mentioned, part E is pretty cool. It's a really fun thing to do, but there's just no way that I could. There's just logistically no way I could have you do something similar to it by yourself on your computer at home, which is kind of a bummer, because it is pretty fun. But there's just, unfortunately, nothing I can do about that. Like I mentioned earlier, there are some questions at the end, so I do expect you to answer these questions in what you turn in for the lab. If you would like to answer the other questions just on these pages here, so we have a couple blank pages there, feel free to do that. If you want to do it on a separate page, that's fine too, whatever you want. As long as I have all the answers that I'm looking for, I don't care whether they're on this particular file or in a different one, as long as I can see all the answers. Okay. Any questions about what you should be doing to make up for missing the lab today?
Is this going to be due at the end of today or with everything else at the end of the week?
It's a good question. Good question. So, I'll answer kind of a couple questions here. So, when you're turning it in, you're going to turn it in like any other online lab. So, you're just going to click on the name there, and you can upload your files here and just turn it in like that. It is set to be due tomorrow. So I didn't want people that missed today to check their email later this evening and be like, oh crud, I have a lab due in 10 minutes. So it's going to be due tomorrow at midnight. Obviously, since you're here and you were supposed to be doing lab at this point anyway, I would suggest go ahead and do it. Honestly, it probably won't take you more than an hour. That's what I would expect. If it takes you more than that, don't feel bad. I'm really bad at judging times. But that's what I'm expecting, is it probably won't take you more than an hour to get all that stuff answered. So you might as well just go ahead and get it done and turn it in. But it is due tomorrow at midnight, just to give the people that missed out on meeting with us now a little bit of time, if they weren't able to show up. Other questions?
Thank you.
Anything else? Oh, and I guess, yeah, by the way, I guess this is the first time you can see my face, so here I am. This is me. My face without a mask, anyway. Um, Might be the last time you see it for the semester. I hope. I hope we can meet on campus next time, but we will see. If I guess before I let you go, are there any other questions just generally about the exam, perhaps, since that's coming up as well? No. No, you will not have to download Respondus. I am going to trust you to be a trustworthy student and not cheat. And there's a few reasons that I'm not using a lockdown browser. Um, there's really two reasons. The main reason is that the only lockdown type browser that I would trust at this point is HonorLock, and HonorLock requires that you also have a webcam, and I know not everyone has a webcam, and I would not want to force not super expensive, but webcams can be decently expensive. Like, I wouldn't want to force you to buy a $30, $40 thing just to take the exams, not knowing at the beginning that you needed to do that. Now, if I had decided to use HonorLock for the whole semester and I told you up front that I expected you to have a webcam, that would be different. Because before the semester starts or in the first week of the semester, you can back out and get all your money back and move to a different section. But to drop that on you partway through the semester, I don't think is right. And so, because HonorLock's the only one that I would consider using, because I think it's the only one that really works, and it requires webcams, I can't really do that. And I guess the second part to that is, the second reason why I'm not having you do that is because I don't really think the other ones work. Like, I know that Respondus does in fact lock down your computer, so you can't access stuff online on your computer, but it does not lock down everything. We have these little things called a cell phone or a tablet, and unless you are somehow able to make the students also lock those down, it doesn't really do any good to lock down the computer you're taking the exam on. So I am trusting you to be a trustworthy and truthful student and do your best with you. I am expecting you to have your book. Um, so I'm not expecting you to look up answers. That is academic plagiarism for sure. But I am expecting you to be using your book while you're taking the exam. Yeah, yeah, and the charts and everything. That's any stuff that I give you. Did I upload that to? I know I did in one of my classes. Did I do that in any other ones? Yeah. So the helpful handouts here on the syllabus and safety link. If you haven't noticed that I put that there, I apologize. I don't think I sent out an email about it. But on the syllabus and safety link tab, I added some helpful handouts. Anything on there I expect you to have as well. So there's a periodic table on there. If you don't want to be like flipping through the pages of your book looking for stuff, I would encourage you to print that out beforehand. And I really think just that periodic table and useful conversions factor sheet, that's really all you need for the first exam. None of the other stuff is going to be useful at all. Like the electronegativities, gas laws, solubility, we haven't talked about that. I don't believe anyway, so those aren't really helpful.
About how long is the exam?
Oh, how many questions is it? Let me see. Exit the student preview here. It is 38 questions.
Okay.
So 38 questions. Most of the questions are very short. And I don't remember there being any that are really long. But there's, a lot of multiple choice, some true false. There's quite a few questions where it's just like one calculation, like converting from one unit to another unit, and it's just a single conversion factor that's needed to do it. And there'll be some other ones where you would need two, and I think I put in one or two questions where it's more than two conversion factors, but I didn't put in very many of those. At most it would be one or two, where you would need three or more conversion factors. And honestly, probably the ones that need three or four, it's probably mostly because it's like a cubed unit. So if it's a cubed unit, I would count that as three conversion factors that you need to use.
And it's over all of Unit 1, so chapters 1 through 5.
Yes. Yep. Yes, indeed. Any other questions? Okay, I'm going to go ahead and stop the recording then.